Hello students. Okay, what we're doing in this series of videos is teaching you how to solve what are called linear equations. But we're going to just talk about a few things first before we actually start solving the equations. Okay, now here's an example of quite a complicated linear equation. So at the end of this series of videos, you'll be able to solve that equation. And what solve it means is find out what number you can put in place of the variable m there, there, and there to make that a true sentence. In other words, the value of this expression on the left will be exactly the same as the value of this expression on the right. Now the reason I've put this up here is that's very hard to do just by trying to do it in your head. Some of the easier equations, a lot of the students that I've taught in the past, excuse me, can actually solve the equations in their head, and then they say they don't need to write anything down because they can do it in their head. So if you can solve this equation in your head, then maybe you have a point. Otherwise, certainly my recommendation is show all you're working. Okay, now the underlying basic fact about solving equations is writing equivalent equations. So I'll give you an example. I'm going to write about the simplest possible equation I can, which is y equals 2. So if I asked you what is the value of y in this equation, you'd sort of say, well, obviously it's 2. That's what it says. Now what if I doubled both sides? So if I doubled the y and got 2y, and I doubled the 2 and got 4, and asked you what is the value of y that makes this equation true? Well, 2 times some number is 4. Once again, the value of y is 2. So the solution to that equation is exactly the same as the solution to that equation. And that's what we mean by equivalent equations. Let's do one more step. Let's say that I decide to add 1 to each side. So on the left-hand side, I get 2y plus 1. On the right-hand side, 4 plus 1 is 5. And again, the question is, what is the value of y that makes this equation true? Well, a lot of students can do this in their head and say, well, 2 times 2 is 4, plus 1 is 5, so therefore y equals 2. So because these three equations all have the same solution, they're called equivalent equations. Now, when we're solving equations, we usually start with an equation like this. We've got to work backwards to that equation and eventually back to an equation that is the answer, that tells us what the value of y is. Okay, here's a metaphor for this. Let's say that this young lad is in the house and he wants to go outside, but it's raining. So what he has to do before going outside is put on a raincoat so he doesn't get wet. So going outside, the step that he has to do is raincoat on. Okay, once he comes back inside, then what he has to do is take the raincoat off. So to undo putting on a raincoat, it's pretty simple. You take it off. And we use a similar sort of concept for that when we're solving equations. So for example, I started here with a number, which I'm calling y. I added 5 to that, and I got the answer 9. So to find out what the value of y is, I have to undo the adding 5. Well, the opposite of adding 5 is subtracting 5. And like I did in the previous example, I have to do it to both sides. Add 5, subtract 5 goes to 0, and y plus 0 is just y, and 9 minus 5 is 4. So for this particular equation, if y is 4, then that's the solution to that equation. Looking at this equation just here, I've got some number. The operation that's been performed on it is subtract 3. So I've got to undo that to get back to what the original number was. Well, the opposite of subtracting 3 is adding 3. Subtract 3, add 3, cancels out, leaving just the h, and 7 plus 3 is 10. So the original number, h, must have been 10. And we can check that 10 minus 3 equals 7. Third example, I've got some number p, and the operation that's been done to it is multiply by 3. Well, the opposite of multiplying by 3 is dividing by 3. The way I like to show division in equations is using the fraction bar. 3 goes into 3 once, so that's going to be 1p, or just p. Negative 12 divide 3, well, negative divided by a positive is a negative. 12 divided 3 is 4. So the original value of p, the original number p, was equal to negative 4. Quick check, 3 times negative 4 does equal negative 12. And the last example of these one-step equations is m is divided by negative 2. Now the opposite of dividing is multiplying. I like to use the dot to show multiplying. It's going to multiply both sides by negative 2. If I put a times there, some students might confuse it with the letter x or the variable x, so that the dot is less confusing. Negative 2 divided negative 2 is equal to 1, and 1 times m is just m, and 6 times negative 2 is negative 12. Quick check. Negative 12 divided negative 2, well, a negative divided by a negative is a positive, and 12 divided 2 is 6. So that, in fact, is the correct answer. So that's how we solve one-step equations. So in the next video, we'll show you what to do if you have two operations done on a variable.